All right, we are finally on one of my favorite parts of probability trees. And first, we're watching the video together. I'm doing the video, you're watching it. Remember, watch what you need. Pause, replay if you have that desire or that wish. And it is really a parent who is either reading their ebook or looking at the videos based on what you are turning in for your daily work. So let's finish strong. We have a person named Scott, and he has a job at a place called Crazy Creations Ice Cream Shop, and he gets to design new ice cream flavors. The company has just received some new ingredients, and Scott wants to be sure to try all of the possible combinations. He needs to choose one from each category to create the new flavor. We have a base flavor to choose from, chunky mix-ins, and fruit swirls. Yum, yum. List 3 different combinations Scott could try. Make sure you use the word and. How many different combinations do you think there are? Well, 3 different combinations. Vanilla and sprinkles and berry. That's 1. 2, vanilla and toffee bits and grape. There's 2, and I guess we'll squeeze 3 up here. We'll do a chocolate and sprinkles and apricot. All right, so I've got 3 different flavor combinations. The second part of that question asks us, how many different combinations do we think there are? Well, we could make a list, but that would take a lot of time and require a lot of writing the same words over and over. Because there are more than 2 options, a probability table is also challenging. An alternative is creating a probability tree to show the different combinations. A probability tree like the one started at right shows the different possibilities branching off each other. In this case, the 2 segments on the left show the base flavors. We've got base flavor vanilla, base flavor chocolate. Each different mix-in choice branches off the base flavor. So we've got our hazelnuts, sprinkles, and toffee bits. And then the first letter, and each different fruit swirl branches off each mix-in choice. So then we've got our different fruit swirls. The first letter of each choice is used to label this diagram. The bold line in the diagram shows the combination vanilla, toffee bits, and plum. Swirl. We are supposed to complete the probability tree to show all the possible combinations. Now, I like to make this as easy as possible when I'm doing the probability tree. So I like to keep all of the letters in order here when I get to the end of the tree branches. So as we fill in the part that is not filled in up here, you'll notice I'm just going to go ahead and put these in the same order. And one more time. And I've put this together in Cami for you. So now we have chocolate, we have our hazelnut, and we need to have 1, 2, 3, 4 off that. Then off our chocolate, we also need to have our sprinkles. And again, we need to have 4 off that. And off our chocolate, we also need to have our toffee bits. And we need to have that off of those as well. So if we keep this pattern going, we would put apricot, plum, berry, grape, apricot, plum, berry, grape, apricot, plum, berry, grape. Now, to figure out all the combinations, I look at the farthest part of my tree. I don't start where it began. I don't go to the first place where it branches. I go to the end. So here I've got 4, 8, 12, 16, 20, 24. 24 possible. I'm going to write that down. 24 possible. If I can figure out how to write the word possible, again, we'd be in good shape there. 24 possible. And so then we move down to the next part of this assignment. How many different flavor combinations are possible? We just said 24. Where do you look at the diagram? You look at the outer branches. At outer branches. And let's use our probability tree to figure out the probability that Scott's final combination will include plum swirl. All right, so we need to figure out where plum swirl is here. We've got, and I'm going to highlight these. Okay, we've got this one is plum swirl, 2, 3, 4, 5, and 6. Now, when we're writing probabilities, we need to make sure that we're writing them correctly. So we can write this as 6/24ths, or we can reduce that to 1/4, or we can call it 0 and 25 hundredths, or 25%. If you do not write them in the correct form, it is not precise, it is not accurate. What is the probability that his final combination will include hazelnuts? Okay, hazelnuts is going to be a little bit more complicated because we have to look at this one. This one has hazelnuts, and there's 1, 2, 3, 4. This one, this set has hazelnuts, and that's 5, 6, 7, 8. Not really complicated. We just have to make sure that we're looking at the right data. And so this would be 8/24ths, or 1/3, or 33%, or we could do decimal.